Welcome, dear students, to this lecture on BSP 403 Analog Systems and Application. So, we were discussing about operational amplifier. In the last class, I told you something about the concept of virtual ground in operational amplifier. Okay, and then we have also seen what is the effect of negative feedback in operational amplifier. Okay. So all those things we have seen in the last class. So from today, we will see the application part of operational amplifier. Okay. You know that operational amplifier are so called because they can perform different operations like addition, subtraction, summing, okay, and integrating, differentiating. I mean, all these they can perform. Okay, so that is why they are known as operational amplifier in earlier days. Okay, initially they could perform all these operations, so that is why the name was given as operational amplifier. So we will discuss all these applications, okay, one by one. So we will begin our discussion today first with uh, two important applications I will try to discuss today, that is inverting amplifier and non-inverting amplifier. Okay, so how you can use operational amplifier as inverting and non-inverting amplifier first. Then after that, in the next classes, we will discuss about the summing amplifier, differentiation, how it can work as differentiator, integrator, and I mean all those things we will see, okay, in the upcoming lectures. So today, okay, let me share the screen and then we will discuss about the inverting and the non-inverting application of operational amplifier. Okay, so I am presenting my screen. So here we go. Okay, so let me open the note where I will write. Okay, so let's begin our discussion. Just a second and I will start. All right, so okay, the topic of discussion is application of operational amplifier. Okay, application of op amp. So the first application we will begin with, that is our inverting amplifier. Okay, so let us see this inverting amplifier, then we will also discuss about the non-inverting amplifier. All right, so I'm just writing here inverting amplifier. All right, so I will just draw the circuit first, circuit diagram, and then we will try to find out the gain here. Okay, our main point is to find out the gain in this circuit. So quickly, let me try to, and you know, inverting amplifier, we call this as inverting amplifier because the input should be given to the inverting terminal. Okay, then we will call this as inverting amplifier. So there are two terminal here, inverting and non-inverting. So since this is an inverting amplifier, we will uh, give a zero potential to the non-inverting amplifier, the non-inverting input. Okay, and in the inverting input we will give some input through this resistance. Let us say it is Ri, the input resistance. Okay, so we are giving some voltage here in the inverting side of the amplifier, and as I told you that most of the time we will be discussing the concept of negative feedback always. Okay, I mean the majority of the time. So we will have a feedback network here, and some output voltage is feedback to the input through this resistance, which is known as Rf, and here we will have the output voltage V out. So this is the circuit diagram of inverting amplifier. Okay. Now let me first tell you a few points about this. Then we will go to the uh, gain part. I mean the derivation of the gain of this amplifier. All right. Okay. So here you know that this V in, you can see this V in here. It is applied through this resistance Ri to the inverting input. So you can see to the minus input, it is applied to the inverting input. Okay. And you know that the output, the output is feedback to this input through this feedback resistor RF. Okay. Now the plus input terminal, you see, this is the plus input terminal. It is connected to the ground potential, or you can say it is grounded. So since the plus terminal is grounded and input is given to the minus terminal, so that is why it is known as inverting amplifier. Okay. So, and the output would be out of phase with the input in this kind. Okay. Now, all right. Now the voltage gain. Let us see the voltage gain of this amplifier. So the next part is your voltage gain. Okay. We'll try to derive the expression for this one now. Uh, you know that an op amp has infinite input impedance, is not it? Here, the impedance between this plus and the minus terminal, it is infinite. Okay, the input impedance is infinite. So, what is the meaning of this? That whatever current is coming from here, okay, let us say whatever the current is coming from this voltage V in, it will not go to this inside the operational amplifier, it will go to through this feedback resistance. Okay, all the current, whatever current is coming from here, all the current will go through this output feedback resistance, because from the characteristics of operational amplifier, we have seen that the input impedance is very high. Okay, so you can assume that whatever current is coming through this Ri, the same current will go through this Rf. So this is the one point which you should remember. Okay. Now the another point which you need to remember here is that now this point, I am marking this point with a red dot here. Now, what is the potential at this point? Using the concept of virtual ground, what should be the potential at this red point? Uh, the potential should be VA should be equal to 0. So let us say the potential at this red dot is written here, VA equal to 0. And how this is 0, I have already explained you in the last class using the concept of virtual ground. Okay. So the potential at this point is VA equal to 0, and whatever current is flowing through this one, all the current will flow through this feedback resistor, because input impedance is very high, so no current will go through this. Okay, so these 2 points you remember. Now keeping these 2 points in mind, we can start the expression, the derivation. Okay, in fact, before I start the derivation, I think it will be better that if I just draw the symbol of this current. Okay, so let us say due to this voltage, we have the voltage drop here. In fact, I would like to use a different color here. Okay. So the voltage drop is plus minus. So due to this one, there will be one current flowing like this here. Okay. So let us say this current is I in. Okay, the input current. Now, as I told you that the current will come to this node and it will have two paths to go. Now this path is very high impedance. Okay, input impedance is almost very infinite, very high. For ideal op amp, it is infinite. So therefore, we will say that all of this current will go through this feedback resistance. So therefore, all the current, whatever current I one is coming, that same current will go through like this. So let us say this current is known as IF, the feedback current. So now you can say that this IF, now you can write that I in should be equal to IF. Okay, using the concept of virtual ground and using the concept that the input impedance of op amp is very high. Sorry. So this is the condition now. So therefore, the current here in this case it is a 0. You can even name this current as I1 also. You can write a small I mean the current I1 here and make this current to be 0. Okay, so anyway, even if you write it or not write it, it doesn't matter. If you make the assumption, then it is okay. So we have this I in equal to IF. So let us begin from here itself, that the input current is equal to the feedback current. Okay, now what is input current? We can write down the value of input current, I input. What is the expression for the current? Current is equal to voltage divided by resistance. So now since the current is flowing through this resistance Ri, so this current voltage would be voltage across Ri. So voltage across Ri क्या होगा? So I am just writing here voltage across Ri divided by V divided by R. Now R is nothing but it is Ri. Okay, Ri. So now you people can tell me what is the voltage across Ri. The voltage across Ri is this voltage, the input voltage V in minus this potential, the red one here. That red one is VA. So the difference between this potential is nothing but the voltage drop across Ri, is not it? It is very simple from this circuit, that if here you are applying 10 volt, then if you subtract 10 volt from this particular potential, then you will say that that is the potential at this Ri. So the potential across Ri is V in minus VA. So VA is here. Okay, so here I can write that it is V in minus VA divided by Ri. Okay, so now let us move further. So this implies that IN should be equals to V in, this should be small v, okay, V in minus 0, because VA is 0 using the concept of virtual ground, and this should be Ri. So IN is nothing but it is V in divided by Ri. Okay, so this is what do we get the value of IN. Now I need to find out IF also, then I will evaluate these two relation. Okay, so let us say this is our equation number 1. So now IF, what would be IF? The current IF. Let us go back to the circuit and see IF. So if you want to calculate this IF, you need to, you need to find out the drop across this one. Okay, now what is the drop across this one? The drop across this is nothing but, since the current is flowing like this and the current is flowing in this way, so the drop across this one you can find out by differentiating this potential minus this potential, output potential. Okay, so the potential drop across RF would be just like the previous one. You calculate the drop across R1, V in minus VA. Now you calculate the drop across RF. The current is flowing in this way, so it would be VA minus V out divided by RF. Okay, so let me just write VA minus V out divided by RF. So this should be equal to, now what is VA? VA is 0 using the concept of virtual ground. Okay, and then it would be 0 minus V out by RF. So that would be minus V out by RF. So it is minus of V out divided by RF. So you can put this as equation number 2. So now from these two equations, equation 1 and equation 2, I in is equal to IF, is not it? That means V in by Ri should be equal to minus V out by RF. Okay, so therefore I can write V in by Ri should be equal to minus of V out divided by RF. Okay, now our aim is to calculate the gain. तो गेन कैसे मिलेगा? अगर आउटपुट वोल्टेज को हम इनपुट से डिवाइड करते हैं तभी गेन मिलेगा. ठीक है, तो व्हाट वी विल डू हियर, V out divided by V in. Try to find this relation here. Okay, So if I find out this relation, then it will be like, okay, I can say that the gain should be equal to V out divided by V in. Okay. Now what is V out by V in? If you take V in this side and RF the other side and negative sign the other side, then it will get minus RF by RI. So you will get minus of RF by RI. So this is nothing but this is the closed loop gain. ठीक है, तो इसको हम ACL के represent करेंगे. Why this is closed loop gain? Because you see that we are calculating the gain for a feedback amplifier. That is why this is the closed loop gain. Okay. So this is what do we get the value of gain. So the gain that is V out by V in, it is given by minus of RF by RI. And why we are getting the gain negative here? This is very much obvious because the amplifier which we are using, it is a negative feedback amplifier. Okay. So this negative sign indicate that the output voltage, the phase relationship between the output voltage and the input voltage is 180 degree. That is what this negative sign signifies. Okay. So that is why we got the gain to be negative. Now a few points you need to remember here. The first point is that the gain of such kind of inverting amplifier, which is ACL, it is the ratio of feedback resistance and input resistance. So you can control the gain by controlling the value of these resistances, isn't it? Let us go back to the circuit and see. Now you can control the gain by keeping the value of RF and by controlling by the value, these two values, RF and RI, you can control the gain. Okay, fine. So that is one point you need to remember. The other point is that the inverting amplifier, we can design this inverting amplifier for a unity gain also. Unity gain के लिए हम इसको डिजाइन कर सकते हैं. Then what would be the value of these two? If I want the gain to be 1, okay, if I want the gain to be 1, then RF should be equal to RI. That means if you are taking RF to be 3 kilo ohm, you should take RI to be also 3 kilo ohm. So that this 3 kilo ohm, it will get cancelled out and then you will get 1. That means the gain is unity. So you can even design inverting amplifier as unity gain. So the condition is that the value of RF should be equal to RI in that particular case. Okay. Now, if we select the precise value of this RF and RI, okay, then we can obtain a wide range of voltage gain. है कि नहीं? क्योंकि अगर हम इसका वैल्यू अलग अलग लेते हैं तो हमको बहुत ही वाइड वैरायटी ऑफ गेन मिलेगा. ठीक है. So these are the important point which you need to remember from this circuit. Okay. So now before I go to the next application, I would just like to share with you a few numerical examples which are based on this inverting amplifier. Okay. So let me go to these numerical examples starting from the first one. So these are like 1 or 2 marks questions. Okay. It's not very difficult. So the circuit is given to you here. So this is the question. I'm just drawing the circuit here. Negative and positive, inverting and non-inverting. So non-inverting is grounded, and we give some input to the inverting through this resistance Ri. Okay, and let us say this is our input voltage which we are giving. So I will call this voltage to be V in input, and let us call this resistance Ri, and of course we will have the feedback here. Okay, so the feedback, let me quickly try to draw this. Yes, okay, RF, then I will have here V out. Okay, so let us say the value of Ri is 2.2 kilo ohm. I'm just writing K here. Okay. Now the question is you need to find out the value of RF. What is the value of RF? This is the question. Circuit is given to you, and the value of gain is also given to you. Gain is given to you to be minus 100. गेन क्यों माइनस है? क्योंकि ये इन्वर्टिंग एम्पलीफायर है, इसीलिए गेन माइनस है. ठीक है. So this is a one-step question. Like you can expect such kind of in university exam as well as in other competitive exams also. Like you can expect this sort kind of question for MCQs. Okay, like the circuit may be given to you, and then it may be asked that what will be the gain of this circuit, given that these are the values. So most probably 1 or maximum 2 marks. Okay, so it's very simple. Now you know that what is gain, how the formula for uh, finding out gain is equal to minus in inverting amplifier, this is the formula for gain, minus Rf divided by Ri, which we have just now completed, is not it, calculated. So now what is the gain here? Gain is minus 100, so I'm just putting minus 100 here. And what is the value of Rf? We need to calculate it, minus Rf divided by Ri. So Ri is 2.2 kilo ohm K. So now it's a very simple calculation. You cancel this 2 minus sign, you multiply this 2.2 with this 100, that would be your output voltage, sorry, output resistor. Okay, so you can calculate it and find it out, Rf. You will get it to be around 220 kilo ohm. I'm just writing K here. Okay, so a very simple question. Now another a little bit tough than this one. Let us try to see. Then we'll go to the next application. Okay, that is the non-inverting one. So another one very quickly. Let us try to see. Suppose another circuit diagram is given to me. So this is also a it is also inverting one, inverting amplifier. Okay, so all right. So sometimes the input voltage may be given in the form of waveform only. So there you need to decide it. You need to see properly and you need to decide how to solve it. Okay, so you should not get confused there. So this is 40K. Now you know what is this. This is the feedback RF. Okay, and here I have V out and this is my RI. So let's say RI, it is given that it is 1K and some voltage is applied here. Now this is it is not written in the question directly, but it is given in the form of this diagram here. Okay, so this is the voltage given to you, it is applied here. Okay, so this is 0 level and here you have 0.5, this is plus 0.5 and here you have minus 0.5. These are in voltages. Okay, so I'm just writing V here. So this is the input voltage. Now the question is, you need to draw the output waveform. How will the output waveform look like? That one you need to draw. There may be 4 options given to you in your questions that pick up the correct answer for the output waveform. Okay, you may get such kind of questions in many competitive exams also, like some input potential is a voltage waveform is given to you and then you are asked to calculate the output. What will be the type? Okay, you may need to choose. So to do that, let us try to first, सबसे पहले क्या करना है, आप सर्किट देखो. ठीक है, ये सर्किट, व्हाट इज दिस सर्किट? दिस सर्किट इज इन्वर्टिंग एम्पलीफायर. इन्वर्टिंग एम्पलीफायर है तो ये पक्का है कि जो आउटपुट का वोल्टेज होगा, और ये इन्वर्टिंग एम्पलीफायर है, जो आउटपुट का वोल्टेज होगा वो यहाँ से स्टार्ट होगा. ठीक है, उसको ऐसे उल्टा होना चाहिए, लेकिन कितना लेवल तक जाएगा ये आपको निकालना होगा. ओके, कितना वोल्टेज लेवल तक जाएगा. ठीक है, that you need to find out. And yeah, one more thing, it is given here, the saturation voltages are given, like this is your plus 15 volt and this is your minus 15 volt. Okay, this saturation. So your nature of the potential should be like this, but up to which level it will go, that we need to find it out. Okay, so let me erase this one, we'll come back to this later on. So all right, so to do that, first we need to find out the amplitude of the output. Okay, amplitude of the output, that we need to find out. So to find it out, the amplitude of the output, let us since this is a negative inverting amplifier, how will you find out the gain? We know that the closed loop gain that is given by minus of Rf divided by Ri. Okay, so now what is Rf here? RF is minus 40. It is in kilo ohm, and RI is also kilo ohm. So no need to change the unit. Leave it as it is. So you will get this to be minus 40. Okay. So the gain you find out to be, see, from the gain itself, since the gain is coming out to be negative, the output voltage should be inverted. I mean, it should be 180-degree out of phase with the input. Okay. Now let us calculate V out. Then we will draw the waveform. Okay. So therefore, what is V out? V out should be equal to the gain into input. So that is nothing but ACL into input, VIN. ठीक है. तो अभी हम पीक वोल्टेज निकाल रहे हैं, तो इनपुट वोल्टेज क्या होगा? Input voltage is given to you, this one. I am not saying the peak to peak voltage. If it is asking peak to peak, then your voltage should be 1. Peak to peak is 1 volt. But here we need to put the maximum value of this voltage. The maximum value is 0.5 volt. Okay. So the input voltage is nothing but it is 0.5. The amplitude you see, it is 0.5 volt. You need to put that amplitude. Okay. So ACL is minus 40 into your input is 0.5. Okay, input is 0.5. So if you do the simplification of this, I think you will get 20, is not it? 4 into 5, you will get 20. So you will get minus 20 volt. You see, minus 20 volt. So this negative sign indicates that the output voltage is out of phase. So now a very interesting thing here, the question is asked to you to draw the output waveform. Okay, so how would you draw the output waveform? You will just draw it here like this, and then you will draw the waveform like this, and then you will say that this is my 20, minus 20, and here you will have plus 20. But this is not correct actually. Okay, the out of phase, this is okay, fine, but this answer should not be correct. You should not pick this answer in any case. Why? Because you got the output voltage to be 20 volt, but you see that what is the saturation voltages here? The saturation voltages is plus 15. That means up to how much maximum value the output can go? The output can go up to a maximum value of plus V saturation plus minus 2 volt. That means if it is plus V saturation, then it will be plus 15 minus 2 volt, that is 13 volt. It can go maximum up to plus 13 volt, and it can come maximum below to minus 13 volt. After that, the voltage would be saturated. Okay, so therefore, because the output we are getting more than the supply potential, supply voltages, so output can never go to plus 20 or minus 20. So your right answer should be this graph, where in the graph it is written like this. So let us say your graph goes like this, and then it will get saturated for some time, it will come back, and then it will go in this way. Here again it will get saturated, and then it will come back. And this saturation mark should be 13 volt, and here it should be minus 13. So this is your right answer. Okay, draw the output waveform. So this should be your correct answer. This is the output waveform where your op amp is saturated now, because you are getting the value of output voltage too large, which is greater than the supply voltages. Okay, that means your device is not working as a linear device here. That is why you see, this is the point which I am repeating every time, that if your device is not working as a linear region, as a linear amplifier, then you will not get a proper output. You see, in the output some portion is clipped off again, is not it? So it is not functioning as a proper amplifier in this case. Okay, fine. So yes, this is the questions. Now I have a few more questions, so I would actually suggest you people to go through those questions. I have written the questions here, and it is related to peak voltage. Okay, so that one I suppose that you people can just have a look at it. Okay, so I will discuss another now application, that is, first we have discussed the inverting application, isn't it? So we will now discuss the non-inverting amplifier, where the input will be given here to the non-inverting terminal. So in that case, we will try to find out the gain. Okay. So very quickly, let me go to the second one, that is my non-inverting amplifier. Okay. So the input will be given to the non-inverting terminal, as I told you. So here now let me quickly draw the diagram again. So this is my minus and plus terminal. Now the input would be given here. So let us say this is my input V in. So V I N in. Okay. And the other is grounded. And let's say we have some resistance here, and then it is grounded. No potential is applied here to the other inverting input. Okay, so we will call this as Ri, and this would be my feedback resistance Rf. And of course, sometimes these supply voltages are not given, but let us write it: plus V and minus V. So these are my supply voltages, and here you will obtain the output voltage. Okay. All right. So now, why do we want such kind of non-inverting amplifier? Because now, what will be the function of non-inverting amplifier? Let us try to understand that first. We have seen earlier that whenever we will give any input signal like this, we will obtain the amplified output, but it will be in the same phase. You see the phases of these two. So there may be some application where you need to obtain the output which is in phase, okay, with the input. So in those applications, it may be any applications. Suppose you want to design a circuit where you want the same phase as the input and the output. So you can use this kind of non-inverting operational amplifier there. Okay. So that is why we need to, discuss this non-inverting amplifier as well. Okay. All right. Now the potential at the point, this one, I am marking this point here, the red dot, the point A. ठीक है. Point A का potential क्या होगा अभी? If any students can answer, can you answer, anyone? What will be the potential at this point, red dot? You can try. I mean, if some students can try to answer this. All right, so let me tell you that you can use the same virtual ground concept again. That means the potential at this point, if I write it in red color again here, VA, let me call this as VA at this point. Okay. Now this VA is nothing but it would be your V in. Okay. VA is nothing but it would be your V in, because we are again using the same virtual ground concept. I mean, whatever is the potential of this, whatever is the potential if of this terminal, plus terminal, now it is not 0 volt, now it is V in. Now that same potential would be at this node also. That means the voltage at this point is V in. Okay, fine. So that point you need to remember. And one more thing you remember here is that now the op-amp, you know that the input impedance, that means, as I already told you in this section only, that the input impedance is very high, so the current will not flow through this one. Now in this particular case, since this is a same phase, you will get the same output phase. So the current, now see here, you are not giving any potential, the current will not flow in this way. Okay, the potential is generated here, so that means you can expect the current to flow like this. Let us say this is your feedback current. Now whatever the current is flowing through this feedback resistance, which is the feedback current, that same current will flow through this input resistance and it will be to the ground potential. Okay, same current, because the current will come to this point, and from this point it will not go to this side, because the input impedance of op-amp is very high. So whatever current is flowing through this, all the current will flow through Ri also. The same current will flow through Ri. Okay. This important point you should note it down. Now let us try to calculate the voltage across Ri. What would be the voltage across Ri? Now this is different case. In the previous one the current was flowing the other way. Now here the current is flowing in this way. So the potential drop will also be plus minus in this way. Similarly plus minus. So you will have to subtract this value to this value if you want to find the potential here. That means V out minus VA. And if you need to find the potential here, it would not be 0 minus VA. It would be VA minus 0. All right, VA minus 0. That would be the voltage across Ri. So therefore, let us calculate it. Let us go down here. I'm going to the next page. So first I'm writing the voltage across Ri. Okay, so this Ri, as I told you earlier here, this Ri you see, Ri ka voltage, it will be VA minus 0. Okay, and what is VA? VA is nothing but it is V in, using the virtual ground concept. Okay, so this potential across this one is nothing but V in minus 0. Okay, so therefore I will write here V in minus 0 divided by Ri. Sorry. It is not the current, so it is actually the voltage, so there would be no division by R actually here. Okay, so this is the voltage, so it is nothing but it is V in. Okay, so similarly the voltage across RF. अभी RF का voltage क्या होगा? Let us go back to the diagram. RF में प्लस माइनस ऐसे ड्रॉप हो रहा है अभी, ठीक है? तो this voltage is nothing but this output voltage minus this VA. That means V out minus VA. VA is V in. Okay, so it is V out minus V in. So therefore it is V out minus of V in. Okay, so this is the voltage drop across the feedback resistance RF. Now since the current across Ri, that means the input current I input, that should be equal to I feedback. Whatever current is flowing through the feedback resistance, the same current will flow through this input resistance. Okay, now what would be the input current? Input current is the voltage drop across Ri divided by the resistance. Okay, now what will be the voltage drop across Ri? Okay, that should be V in minus 0. You see, this is the voltage drop, V in minus 0. Okay, so I will just write here V in minus 0 divided by Ri. So this is equal to the feedback current. The feedback current is this potential divided by RF. Okay, so it is V out minus V in divided by RF. So now you can find out the gain. Why we have written the equations like this? Because we want to calculate the gain. Okay, that is why. So you can do some simplification. So this expression, from this expression, this 0 part will cancel out. So it will be just V in minus V in divided by Ri. And here you have V out by RF minus V in by RF. So if you do some simplification here, maybe I will not be showing you each and every step. Okay, you can calculate that actually. So if you do the simplification, you will get V out divided by V in terms of just these resistances RF and Ri. Okay, so this would be nothing but you would get RF plus Ri divided by Ri. Now if you do further simplification, like you separate these terms, then it would be Ri by Ri, that is 1 plus RF by Ri. So you will get 1 plus RF by Ri. So this is the expression for gain. ठीक है, ये V out by V in क्या है? ये gain है. ठीक है, so I will write here again, this is my closed loop gain and this is for non-inverting gain. So now inverting gain, you know, inverting gain, it is minus RF divided by Ri. Okay, and non-inverting gain, non-inverting gain, it is 1 plus Rf by Ri. So you need to remember this. So inverting gain we are getting negative, and non-inverting gain we are getting positive. And it is quite obvious also, because here the output signal is in phase with the input signal. Okay, so a few points before I conclude, let me tell you a few points here, that the gain is 1 plus Rf by Ri. Can you make the gain unity here? The question is that, yes, in this case also you can make the gain to be, the voltage gain can be made equal to or greater than 1. Equal to or greater than 1. You can even make the gain equal to 1. If you select Rf by Ri to be like equal values, suppose let us say Rf is 2 kilo ohm and Ri is also 2 kilo ohm, then the gain is unity. Okay, that means the signal will not be amplified. Whatever input signal you will get, you will apply that same output you will get. It will not be amplified. Okay, because the gain is 1, you multiply the output, to calculate output voltage, you multiply the input with 1, you will get the same output. Okay, so it can be made either equal to or greater than 1. If you want this value to make greater than 1, then you should select the value of Rf to be greater than Ri. Suppose Rf is 30 kilo ohm and Ri is only 2 kilo ohm. 30 by 2, it is 15, is not it? 30 by 2, it is 15. So 1 plus 15, the gain is 16. So basically, to get a high gain, or you need to, I mean, increase the value of feedback. So basically the value of feedback should be high as compared to the input resistance. Okay. So those are the important point which you need to remember here. And one more thing, the gain in this case is positive, and the gain in the previous case, which is this one, it was negative. Okay, so those 2 points you remember it, and these 2 important formulas. So if you can, in this case also you can get a wide variety of gain is possible, because by keeping these 2 values, different set of values, you can, I mean, design your own positive amplifier by taking different combinations of Rf and Ri. A wide variety of gain you will get here. Okay, so I hope that this lecture session is clear to you. If you have any queries or question, then you can just let me know. I will try my best to give you an answer. Okay, so since no one of you are saying anything, so I'm just concluding this session. Okay, so with this we come to the, I mean, the end of today's discussion. Okay, on 2 important application of operational amplifier, that is the inverting and the non-inverting amplifier. So as okay, I will provide you the note. If you do not have any question right now, so still if you have some questions, then I can answer that. I've tried to answer that. Okay, so I will give you the notes. Just have a look at the notes, and if you have any doubt, then you are always welcome to, I mean, clarify your doubt. Okay, you are always welcome for that one. So with this, I will conclude this session, and see you guys soon in the next lecture. Okay, thank you all for joining.